Let us say electrochemistry subjective numerical. Electrochemistry subjective numerical. Ninth question will say. Ninth question you see that what is the given data you see. Let us read the question. The SRP at 25 degrees Celsius for the reaction 2 water molecules plus 2 electron gives H2 plus 2 OH minus is minus 0.8277 volt. Calculate the equilibrium constant for the reaction. We have to find equilibrium constant. For which reaction? In the sense, for this reaction we have to find the equilibrium constant we have to find. Okay, let us find equilibrium constant. Let us find equilibrium constant we have to find. Sir, okay. Equilibrium constant for which reaction you see? Water gives H3O plus and OH minus. Sorry. Water gives H3O plus and OH minus. For this we have to find the equilibrium constant we have to find. Okay. What is a given off reaction? In the sense 2H2O plus 2 electrons gives H2 plus 2 OH minus, for which SRP minus 0.8277 volt. Sorry. Now how to find how to do this sum, that we will see. How to do this sum, that point we will see. Now what is the given data? In the sense 2 water molecules plus 2 electrons gives H2 plus 2 OH minus. For this SRP is given. SRP equal to minus 0.8277 volt. What they have asked? They have asked equilibrium constant. Equilibrium constant for which reaction? In the sense 2H2O gives H3O plus OH minus. For this equilibrium constant we have to find. Equilibrium constant we have to find. Okay. Now see this reaction. See this reaction. Here left side water molecules are there. Right side H plus and OH minus ions are there. It is a complete reaction. It is not off reaction. If it is off reaction, either left side or right side electrons will be there. It is not off reaction. It is a complete reaction. Okay, we can say it is a complete reaction. For this complete reaction, they are asking equilibrium constant. For which to find this one, they have given this. Sorry. Now here OH minus is there. Here also OH minus is there. Okay. In the required equation, OH minus is there in right side. In the given off reaction also, OH minus is there in the right side. Sorry. Next, in the required equation, H3O plus is there. H3O plus is there in the right side. In this given off reaction, H3O plus is not there. Therefore, what we have to do in the sense, we have to take the another off reaction in which H3O plus should be in the right side. Sorry, okay. Next, you see, in the given off reaction, hydrogen gas is there in the left side. In the required equation, hydrogen is not there. Hydrogen is not there. So we have to cancel this hydrogen. In order to cancel this hydrogen, we will write hydrogen in the left side. Left side will write. Now this hydrogen is converting into H plus, means by losing electron, let us balance. So we will get like this. Now let us add these two off reactions, whether we will get this reaction or not, we will see. Now this hydrogen gas cancelling. What is the rest? In the sense, here H plus, this H plus is H plus, here H plus, okay. Here OH minus, okay. Here water, okay. Here electrons cancel. So in order to get this reaction, we have to consider the given off reaction, and we included this off reaction. We have taken this off reaction. So here see that for this equation, they asked us to calculate equilibrium constant, for which they gave this off reaction. This off reaction they gave. Now in the OH minus is there in the right side of the off reaction. In the required equation also OH minus is there in the right side. So okay. Next, In the required equation, H plus is there in the right side. In the given half reaction, H plus is not there. Therefore, we are including. So we will write another half reaction in the half reaction in the half reaction which we are writing. In that we are writing H plus in the right side. So we have written H plus in the right side. Here also H plus is there in the right side. Okay. Now in the given half reaction, hydrogen is there in the right side. In the required equation, hydrogen is not there. So we have to cancel this hydrogen. So we are writing this hydrogen in this half reaction. Left side we have written. Now hydrogen H2 gas is converting into H plus ion in the sense by losing electrons like this. Sir, H2 is converting into 2H plus ions by losing 2 electrons. Okay. Now you see that here 2 electrons are there, here 2 electrons are there, cancelling. This H2 cancels. This 2H2O we will write here. 2H plus ions we will write here. 2H plus ions. This 2OH minus ions we will write here. So now we will make this H3O plus as H plus. How many H plus ions we will write in the sense 2H plus ions we will write. 2H plus ions and 2OH minus ions. So this equation we can write as what in what manner means water gives H plus, water gives H plus and OH minus for this equilibrium constant Kc equal to question mark. Now you see that equilibrium constant for this Kc, for this equilibrium constant and for this equilibrium constant will be same or different. How do you feel? Equilibrium constant for this, equilibrium constant for this, equilibrium constant for this. Do you feel that same? Equilibrium constant for this, equilibrium constant for this. Do you feel safe? No. Therefore, what they asked in the sense, they're asking the equilibrium constant for which one you see? They're asking the equilibrium constant for which one in the sense, they're asking equilibrium constant for this. 2H2O gives H3O plus OH minus. For this only they are asking equilibrium constant. They are asking equilibrium constant for this. 2H2O gives H3O plus OH minus. For this we have to find the equilibrium constant. Now see here one OH minus, here also one OH minus. Here H3O plus is nothing but H plus water, therefore it is nothing but 1H plus. Now here two water molecules. These two water molecules becoming one water molecule by cancelling one water molecule here. It is nothing but H plus and one water molecule. No, one water molecule here, one water molecule here. You cancel, then it becomes one water molecule. So this reaction is nothing but this reaction. These two reactions are same, but this one and this one different. Why? Because stoichiometric coefficients here and here different. Here 2H plus ions, but here 1H plus ion. Here 2OH minus ions, but here 1OH minus ion. Therefore, we have to find equilibrium constant. For this, we have to find, that means for this, not for this one. So, you make the off reaction such that you will get this reaction. You do something here, you do some operation here in this off reaction such that we will get this. Sir, okay. So for doing that, what shall we do these off reactions? What shall we do in these off reactions? So first off reaction is there and the second off reaction is there. What shall we do? First off reaction, we will divide by 2. First off reaction, let us divide by 2. Then what we will get in the sense of hydrogen gas gives 1H plus aqueous and 1 electron. For this SRP is how much in the sense 0 volt. SRP is 0. Why? Because it is a hydrogen electrode. Hydrogen electrode, if you see hydrogen gas is there, H plus ions are there, hydrogen electrode, standard condition means standard hydrogen electrode. For standard hydrogen electrode, potential is 0. Sorry. Next we will take this second half reaction. We will take second half reaction. We will divide by 2. Second half reaction also we are dividing by 2. So we are getting a H2O plus electron gives H2O plus electron gives half H2 gas and 1 OH minus. Now what is the SRP value, do you say? What is the SRP value? What is the SRP value, do you feel? What is the SRP value, do you feel? What is the SRP value? How much do you say? SRP value is how much do you say? SRP value remains same. You are correct. SRP value how much in the sense minus 0.8277 volt. We are dividing the off reaction by 2, but SRP we should not divide by 2 because it is intensive property. SRP is intensive property, so don't divide it by 2. So you write this as it is, 0.8277 you have to write as it is. Then we will go for a complete reaction. We'll go for complete reaction. We'll go for cell reaction. Cell reaction will take this hydrogen will cancel, this electron will cancel, and here left side water and the right side is what in the sense H plus aqueous and OH minus aqueous. For this we have to find equilibrium constant. For this we have to find equilibrium constant. We have to find. So how to find equilibrium constant for this, that we will see. Now for this we have to find equilibrium constant. Equilibrium constant, if you want, we will take the relation. What is the relation in the sense E naught cell is equal to E naught cell equal to 0.059 by n log log kc log kc. Okay. Now we want E naught cell. E naught cell for this we want E naught cell for this we want. It is anode. This we can say as anode. This we can say as cathode. So E naught cell is how much means SOP of anode plus SRP of cathode. Okay, that we will take. That is called a E naught cell. Okay. So now we are going for E naught cell. E naught cell is what in the sense E naught cell is equal to SOP of anode plus SRP of cathode. SRP of cathode. Okay. Now see that this anode, for this anode SOP is given, that is 0. For cathode SRP is given minus 0.8277. Okay. So the anode SOP is 0, cathode SRP is minus 0.8277 volt. 8277 volt. So E naught cell is minus 0.8277 volt. That E naught cell value will substitute minus 0.8277 volt. We have substituted. Then 0.059 by n. N is how much we will see. N is here you see that number of moles of electrons you see in the cathode 1. In the anodic reaction you see 1. So number of moles of electrons we will substitute as 1 log Kc we have to substitute. In the Kc what you have to do in the sense this right side thing you write in the numerator. Right side you write in the numerator, left side you write in the denominator. Right side what is there, H plus and OH minus, write in the numerator. Left side is H2O, write in the denominator. Okay, and the numerator what you have to write, right side. Right side what is there, H plus and OH minus. Sir, okay. Left side what is there, water, that we have written here. Sir, next we will write minus 0.8277 equal to 0.059 by 1 log concentration of H plus, concentration of OH minus we have taken. What about concentration of H2O? This concentration of H2O shall we take or not? Concentration of H2O in the sense whether this H2O is a pure water or impure water, that we have to see. Now see this anodic off reaction, you see anodic off reaction is H2 gas giving H plus and electron. Cathodic reduction you see H2O plus electron gives half H2 and OH minus. So resultant is water means H2O is in equilibrium with H plus and OH minus. Now concentration of water. Concentration of water in the sense how much we will take concentration of water. Concentration of water means how much shall we take here? Concentration of water shall we take as 1 shall we take, or shall we take as 55.55 molar shall we take, or shall we take the given value, or the what value they are asking that we have to take, or which value we have to take? Concentration of water means. Concentration of water means. Sir, okay. Now we have to see, we will see concentration of water, how much, that we will see. Now we have to see what in the sense concentration of water. Concentration of water we want. Sir, for which let us take pure water. Let us take pure water, we'll take. For pure water, let us take 1 liter. Now molarity of water. Molarity of water is equal to number of moles of water, by volume of water in liters. Now number of moles of water. Number of moles of water in the sense mass by molecular mass. 1 liter means 1 kilogram. If you take density is 1, so 1 liter means 1 kilogram. Therefore 1000 gram is the mass, and 18 is the gram molecular mass. Per gram molecular mass unit is gram per mole, and volume of water is 1 liter. Volume of water we are substituting as 1 liter. We are simplifying this comes as how much in the sense 55.55 molar. So molarity of pure water how much means 55.55 molar. Okay, we have taken 1 liter, so we got 55.55 molar. Suppose if we take 2 liters, what is the value? Suppose if we take 2 liters, if we take 2 liters here, what will happen? 2 liters if you take, what will happen means moles of water. Moles of water, how much we'll see? Mass of water will be 2 kilogram. Mass of water will be 2 kilogram. Therefore, we will convert this into 2000, and the molecular mass will be same 18, and the volume of water will be 2. 2 we have written. Now also we will get how much in the sense 55.55 molar. So whatever the quantity of pure water, molarity of pure water remains constant. That is how much means 55.55 molar. So if we take a solution, in solution, what is the molarity of water? That we will see. In a solution, how the molarity of water will be there? That we will see. For which let us take 1 molar aqueous solution of 1 molar aqueous solution of NaCl. 1 molar aqueous solution of NaCl, we will take 1 liter. 1 molar aqueous solution of NaCl means 1 mole of NaCl, 1 mole of NaCl plus a certain quantity of water, gives 1 liter of solution. 1 liter of solution. 1 mole of NaCl means that is how much means 58.5 gram. 58.5 gram. You know 1 liter means how much you know? 1 liter means how much you know? Okay, 1 liter means you can visualize that 1 liter solution means how much it will be there, that you can visualize. 58 gram of NaCl, 58 gram of sodium chloride salt, how much you know? You might have seen 1 kilogram of salt packet, you have seen 1 kilogram of salt packet. In that 58 gram means around 60 gram, around 60 gram, how much it will take? Around 60 gram means how much it will take means suppose it is taking this much. Remaining is water. Remaining is water. So water is how much in the sense roughly 1 liter. Roughly 1 liter. Therefore, what is the molarity of water in this 1 liter solution? Nearly 55.55 molar. Molarity of water. Sorry. Molarity of water nearly 55.55 molar. Sorry, okay. Now we will consider this case. This case we will consider. Here, now we will consider pure water. We will consider. We are considering pure water. In pure water, what is there means H2O molecules are there, that is undergoing ionization to give what in the sense H plus ions and OH minus ions. Initially, what is the concentration of pure water in the sense 55.55 molar? It is undergoing dissociation. It is undergoing dissociation in the sense X molar is undergoing dissociation. Pure water is bad conductor of electricity, that indicates that it is not undergoing complete ionization. So it is undergoing partial ionization. So at equilibrium, how much will be there means 55.55 minus X molar will be there, and H plus how much means X molar, and OH minus how much means X molar. Okay. The experimental value says that the experimental value we will see, the experimental value says that at 25 degrees Celsius it is nearly roughly 10 power minus 7 molar. It is roughly 10 power minus 7 molar. That means it is nearly equal to 55.55 molar. So how the concentration of water is there? See, concentration of water almost remains constant. Therefore, concentration of water almost remains constant. Since it is constant, we are not taking this term here. We are not taking this term here. That means what happens to this term? Where it has gone? That we will see. Where it has gone? That point we will see. Now, we will see minus 0.8277 volt equal to 0.059 by 1 log concentration of H plus into concentration of OH minus by concentration of water. Now Kc is equal to equilibrium constant. Kc is equal to what in the sense concentration of H plus into concentration of OH minus by concentration of water. Since the concentration of water almost remains constant, let us take this one into left side. we are taking that to left side. So we are getting a what in the sense H plus into OH minus. Now the product of these two constants, the product of these two constants is called another constant, that is called what means Kw, that is equal to concentration of H plus into concentration of OH minus. Kw is called a ionic product of water because we are taking a concentration of ions in the product, multiplying, we are multiplying concentration of ions. Therefore, it is called ionic product of what in the sense water. H plus into OH minus is water. Therefore, ionic product of water. Kw is called what means ionic product of water, that we can say. Kw is called ionic product of water. So we will convert this equation like this: minus 0.8277 equal to 0.059 log concentration of H plus into concentration of OH minus. So from this what we will get? So we got like this. From this what we will get in the sense we will get this concentration of H plus into OH minus we will substitute as what in the sense Kw. This concentration of H plus into OH minus we will substitute as Kw, we can substitute, so that we will get so we will get this formula as minus 0.8277 equal to 0.059 log Kw. So by simplifying this, what value we will get in the sense we will get Kw. Kw we will get. Okay. Kw value, it is nearly 10 to the power of minus 14. It is Kw is nearly 10 to the power of minus 14, we can say. So answer for this question is Kw. Kw is how much means nearly 10 power minus 14. Okay.